I welcome you all to this session where I have planned to discuss the power converters that we are going to use for renewable energy extraction. And here, since this topic is on hydropower, so I will discuss my focus will be mainly on power converters that we use for hydropower plant and some control aspect of it. So, this is the presentation outline. So, first I will give some brief about how power converters are going to help us. Actually, previously the scenario was different. Okay, maybe 30-40 years back, the aim was to generate the state of art was to generate power from coal based power plant, and then mainly coal, hydro, and then you generate that power and then you transmit that power from remote location and then use it. But current scenario is completely different, where we have distributed generation like solar, wind, this hydro, then fuel cell is coming up, also battery energy storage system. I have heard the scenario where the power utility company is not able to supply power to a particular location. They are planning to install a complete battery energy storage system to supply for that particular location. So, this kind of applications are coming up, and for those applications without power converters we cannot think of. Now, I mentioned about legacy system, this LCC thyristor converter. I will tell you what is the significance of this here, and then how to extract power, renewable energy power. We will see that it is almost similar, whether it is wind, whether it is hydro, whether it is solar. So, how to extract means what should be okay. So, what should be the how it can be extracted and looking at their characteristics. Then grid connected hydro power plant, and these are the two major and popular solution that we have for grid connected hydro power plants that we will discuss. And then how to introduce this multi-level converters for this hydro power plant. Now, first we will discuss with how this power electronics is going to help us in renewable energy integration. So, it is like let us say we get crude oil. Okay, so, crude oil, then what we do, we refine it, and then end product is like say let us say diesel, petrol, kerosene that we use in our daily life. Similarly, renewable energies are available. Till now what we know, a few renewable energy sources that like solar, wind, hydro, and then fuel cell also we are treating as renewable energy. So, but it is like hydrogen is plenty of hydrogen is available, so we can treat it. So, the thing is, the sources are there, the power that they are generating, those are very crude sense. Why, what do we mean by crude sense? Because the voltage is not fixed, the current that is delivered by that source is not fixed, the type of voltage and current that is delivered by that source is not fixed. Fixed in the sense, it depends on whether it is solar, it will be different, whether it is wind, it is different, whether hydro, it is different. So, it depends on what kind of source that you have, and also it depends on various location dependent. If it is wind, it is very popular that offshore wind farms are very popular. Okay. So, that is there. Then when it is solar, then in desert it is very much popular because plenty of space is available, there you can install megawatt level solar plants. In mountain areas also we install some kind of this renewable energy sources, because the conventional grid, it is not always feasible to reach that area. So, and also these are very much dependent on weather conditions. So, the renewable energy source that we are getting, those are crude in the sense. So, therefore, to make this useful, we have to do something. So these are the application requirements. So these are the sources which we want to use. So we need, so this is the application requirement, means we have to filter it out, we have to make it human usable, which is suitable for us. That power form we have to convert. So from load point of view, if we see, so in output side what we have, we need, the initial days it was only AC, single phase or 3-phase AC. Then it is, now we are having DC microgrids and all are also coming up, also DC charging and etc. is coming up. Then the level of voltage will be different, high voltage, low voltage, those voltages will be there. High current applications are also there. There are motor drives application where you need current level higher, high current, or you need both high voltage, high current for high power application. It could be standalone or it could be grid connected as well. And then there are microgrid. So these are what we need, and here the standards are imposed, and this voltage, current and other harmonic content, everything are defined. So here which is very crude, and here which is has to be very sophisticated, or it should be very useful. It should be in such a form that it is useful to our daily life. So this is the load requirement. Now there is a huge difference between whatever application is there, or the renewable energy sources, what are the form that they are generating, and what is we are going to use. There is a gap. So how this gap can be filled? This gap can be filled by power processing unit. So it will process the power from crude sense to usable form. Okay. So here the heart of the power processing unit is power converter, that I will come up. But what are the different components that you must have in a power processing unit are? So first thing, what it could be? The first thing, what you expect, what it could be? The first thing, power circuit will come, but power circuit is the heart of the thing. But there should be many more things which is going to support the power circuit. The first thing is you need a filter circuit, okay, if possible. So if you see any DC-DC converter, the first thing that you have is what? Before the converter, you have the filter capacitor, right? That is filter. So first thing that you need is the filter, okay. At least you filter out crude sense, in a crude way you are getting some power. So at least if possible you filter it out, okay. Same for the output side, okay. So you made something, you converted to some level. Now you put some filter, you don't go further. Power converters, I remember when I was studying in my second year of BTech, one person from industry has came and explained that is still, I feel that word is very much valid. That power electronics is an area using which you can do anything, whatever you want you can do. Whatever voltage level, whatever current level, whatever type of voltage, whatever type of current, whatever you want to do, everything it can be done. Okay. So here without this passive filter also we can do it, but we are saying we don't want to make it further complex. Let it make it simpler. If possible, use filters, and that filters are not active filters, these are simple passive filters. L, C, this you use, or combination of this, and then you make it suitable for input side and for output side also. Then it comes to the power converter, okay. Then the power converter does that conversion it will do. So when I studied power electronics in my BTech, my professor first thing that told that power electronics is not that we are dealing with high power. Power electronics is the area where we convert, this power converter, we convert type of electrical energy to another type. So it is DC is there, you are converting DC into DC, but the types are different, voltage levels could be different. So similarly it could convert DC into AC, AC into DC, AC into AC, everything is possible. So power electronics does this thing. So power converter is there. Then what is that? Power converter is the circuit, okay, power converter. So in order to make it run, what is the next thing that you need? You need a control circuit. So there must be a control. So you must have a control unit. So, you have power circuit, you have control unit, and then what you have is this, okay, sensing unit. So, sensing unit in the sense, this power electronic converter, in order to run it using the control unit, it should not be blind, it must be knowing what are the voltage levels, what are the current level. Similarly, so for both for the input side as well as for the output side. Okay. So, it must know what is coming and it must know what I am delivering. Okay. Then only, so it is this control unit must be knowing, okay, this is what is I am out, my output is this, the output of the power electronic converter is this, but I am not expecting this, I have to correct it. So, in order to know whether it has to correct it or not, it must sense the output. Also, from the input side, input sensing unit you must have, so that it must know what is coming. Okay, you will understand when I explain this power MPPT, that time I will explain how this sensing is going to help us. Then in order to, when you, so this is fine. Okay, if you see in simulation, if you do these components, with these components, if you do simulation and your input is your output is coming fine, we are happy. Then you make an experimental circuit, you validate it, and we are happy. But this is not the case, because when you are validating something, so you must expect that it must go to a product level. Let us say you are making a converter, power converter suitable for some application. So, when you simulate, then you validate, then you must think how it can go to a product level thing. If you think like that, then you must have, this is one of the most important, one is the protection. Why protection I will tell you, but let me tell you another important thing is the EMI and EMC filters, EMI and EMC, yes, EMI and EMC filters. Now, why protection is important here, very much important, because when it comes to a product, protection, input output protection, okay. Why when it comes to a product level thing, what happens, when a company is going to make a product out of it and going to launch in the market, a customer is going to buy it, and that will be based on two things. First, customer does not know how this product is going to work, he blindly will buy. Okay. Based on what? The first thing, he do not have any review from anywhere, because he is the first customer that he is going to use that product. So, he do not have any review. Second thing, then what is the second thing that he is going to see? The price, right. So, price, and second thing is reliability. These are the two major things that a product must have. Okay. So, if you have protection unit in place, then you must improve the reliability of your product. Now, next time that if the person who is first time user, that person will use that product and he will become a reviewer. So, if he is happy with that product, he will give a positive feedback, and next time another customer will come and buy that product. So, in order to improve the product reliability, these protection units are needed, and in order to meet the standard, you need this filters and this EMI filters and everything. Now, one of the major thing that we are missing here is, one of the major thing that we are missing here, can anybody guess? Reference is there in control unit. Okay. Communication, they must communicate with each other. So, everything, so you should have a communication between each and every item, right. So, here this is the complete picture. So, here what we have crude renewable energy sources, and then we need that crude energy source to be in a useful form. So, for that we need a power converter, but to have a power converter you need this necessary components in order to make it work. Okay. Is that clear? Now, today what I am going to do is, today I am going to discuss about this power converter, and for this one, for hydro power plant, I will come to that. Okay, power converter. Now, what happens, depending on this application requirement, or depending upon this renewable source, and depending upon load requirement, the major component that going to change in this item list is the power converter. This is the major thing that is going to change. The type of converter, either it could be a DC-DC converter, it could be a DC-AC converter, it could be AC-AC converter. So that is why this is important. Okay, so today I am going to discuss about this, because the rest of the thing, whether it is sensing unit, protection unit, filter, passive filters and all, this is almost will remain same throughout the platforms. Now control unit also, now we are very happy with the DSP microcontrollers implementation. So this is also almost constant for different topologies. Okay. So today we will discuss about power processing unit, which are mainly the power converter that we are going to discuss. Okay, this is what I already told, that choice of power converter changes with application requirement. Okay, it depends what do you want, depend on that it is going to change. So rest of the system are going to be same, almost remain same. Now why power converters are going to be different? What is the answer to this? Why power converters are going to be different? Applications are different, that is broad sense, that is correct. Different voltage level, right? Different voltage level. So what he said is that is more prominent, because if we, let us say I am talking about let us say a very basic DC-DC converter is a buck converter, okay, but buck converters are not suitable for high power application. Buck converter 100 watt, 200 watt, 300 watt, even 300 watt is high, it's fine. But when your power level, voltage level are going up, I remember there is a very famous problem in industry, okay, I cannot tell you, but that problem you cannot solve using this buck converter, boost converter, you cannot do that. You need some other kind of converter configurations in order to address, and this is still an open problem, and researchers are working, definitely working on it. Okay. So as you told that semiconductor technology is very much means it's growing, but thing is when let us say you thought of an idea and you thought of something, let us say I am giving you one example, vector control you heard of, right? Vector control of induction motor, that is a very famous, okay. It was invented by long back, but it was not able to, industry was not able to accept it. Why? Because that time when it was invented in 1970s or 80s, okay, by a German scientist, what happened? This DSP microcontrollers were not that much readily available in the market, or was not accepted in the power electronic circuit. So because of that, what happened, even if that theory is in place and idea is in place, you can implement it. Since those things were not readily available, it was not accepted by industry, and it is accepted later on. And now this is the state of art of speed control of an induction motor. Okay, vector control and DTC are the two major speed control techniques that almost every industries are using because of high performance. Okay. So here also, if you go for high voltage application, the semiconductors are having limited capability, limited voltage and current capability. Now what happens, then immediately it might you might think that okay, we will connect them in series and then we can make the voltage can make it for suitable voltage level, like just like we add bricks to build a wall, right? We can do that. Definitely we can do that. But the problem is when you connect anything in series, anything in parallel, what happens when you connect in series? Definitely there will be a voltage mismatch between the devices. Okay. So in that case, when you want a very high reliable converter, then you must have the voltage balancing circuit in place. There are active passive voltage balancing circuits. If it is in parallel, current sharing is also a difficult task. So those things are there. So why can't we improve the topology and change the topology so that this voltage balancing things and series connection we can avoid, that we can come up. So for current, so increase the current level. So that is why, so this were the problem, okay, like high voltage, high current. Now what happened, I can tell you this legacy system, I have the slide for legacy system. Now the thing is, thyristor is one of the very reliable and very high power electronic device, okay, though it is not that people think about, people go with IGBT, MOSFET. High power we don't go with MOSFET, we go with IGBT. Okay, IGBT, IGCT, okay, these things we go with. But previous days, this thyristors were the only solution for high power applications. You heard of HVDC, right? In HVDC, I can tell you the transition because I worked in HVDC, so I can give you some glimpse of it. In HVDC, it was thyristor converters only. Okay, previously when it was started with thyristor converters. Okay, and it was installed at various places in the world. Okay, many even in India we have HVDC links way back in 1970s, 1980s. HVDC links are there. Those are completely thyristor based. That time we cannot think other than thyristors. Okay. Another advantage of thyristor is thyristors internal drop is very less, and also thyristor is not very high switching frequency device. So losses are very less. So that is why thyristors, hundreds of thyristors connected in series, parallel, and somehow we are engineers, we made things working. So HVDCs are working and extremely at high reliability. The thyristor, these HVDC links are have very high reliable, means those are very reliable. Okay, but there are some issues come with it because thyristors are semi-controlled device. You cannot turn it off. For that, you need high reactive power at the source and the load end in order to make thyristor commutating, means for thyristor commutation. Then what people thought, like, if we are coming up with multi-level converter, why not use multi-level converter for HVDC? Because the features of VSC, voltage source converters, are far more than current source converters like thyristor converters. Those are current source converters. Now you will see that whatever legacy system were there for HVDC thyristor based, now almost 9 out of 10 projects on HVDC are on VSC based converters. Okay, now people have implemented, it is successfully running. Okay, and it has enormous advantage, VSC converters. Okay, but since it is coming up, this VSC based converter based HVDC is coming up. So now it is the power level that they are implementing, the power level of this thyristor based converters are much more higher compared to this VSC based. Recently India has implemented one 3-terminal HVDC, those are thyristor based, maybe 5-6 years back India has implemented. It is from northeast we have huge amount of renewable energy sources, they are bringing it to Agra. Okay, the northeast Agra, this link is there, you can search over internet, you will see it. So it is through Alipurduar. So first they made one terminal at Alipurduar, from Alipurduar they made to this Agra. Why Agra? Because they are saying it is a central part of India, so it can disperse power from that place. Okay, so that is LCC based. So for high power application, LCC based converters were very much popular. So this is one of the example where synchronous motor drives were using LCC converter, load commutator converters or line commutated converters. So what happened? This is synchronous motor drives. For synchronous motor drive, what happened in older days? It was the synchronous motors were for very high power application, megawatt level drives application. Synchronous motors at high power are efficient than induction motor. That is why synchronous motor were preferred. And since it is a load commutated converter, we run it. So you can see here overexcited. So it is overexcited synchronous motor. Okay. So when you run it at leading power factor, the commutation of the thyristor becomes easier and it is feasible. That is why this was the only solution in older days for synchronous motor drive. So LCC thyristor converters were very popular and for high power application. Okay, line commutated and load commutated thyristor converters. Thyristor advantages I already told you, but it is semi-controlled device, large reactive power requirement, and since I told you it is a current source converter, so slow response is there. So this thing I already told you that synchronous motor drive leading power factor, so load commutation were feasible, and synchronous motor is efficient than induction motor at high power level. Now see the induction motor. Induction motor is such a versatile machine, it is used at each and every application, you cannot avoid it. Even it is so much popular, even it is competing with BLDC motor for electric vehicle. In electric vehicle it is competing with BLDC motor. It is 120 years back it is invented, still its competitor is very less, okay, induction motor. So now this place is taken by induction motor, this synchronous motor drives are taken by induction motor, and this induction motor drives are used by VSC converters. Okay. Now why we are switching from LCC converter to VSC based converter? So now it is DSP processors are readily available, we can control, we can implement easily, and then we have semiconductor technology like IGBT, IGCT, and control of VSC are far more superior compared to LCC. Okay. So because of these advantages, now we have completely switched from LCC based converter to completely, in the sense in some application you cannot think of other than LCC converters. So but rest of the converter we are happy with these VSC converters. Okay. Now for renewable energy sources integration, so what are the converters that we need? You need all the converters. You need DC to AC converter, you need AC to DC converter, you need DC to DC converter, you need isolated DC to DC converter. All possibilities that you need. Why you need all possibilities? So when it is solar PV, the solar energy that you are extracting and then you are giving it to grid, or you are using it for standalone application. Now output of solar is what? As a variable DC, right? So first you convert it into a DC, fixed DC, not fixed DC, because if it is a grid connected, so you need a DC to AC converter. So DC to AC converter, what you do is, first you use a DC to DC converter, where this DC-DC boost converter is one of the most preferred DC-DC converter for this solar PV application for MPPT tracking, and I prefer this converter because you have inductor at the input. This inductor makes the current continuous in the sense, if you see buck converter, if you let us say use buck converter, the current that is going to deliver by this solar PV is discontinuous, whereas because of when you have inductor you cannot think of, generally you cannot think of discontinuous current. So you will have continuous current. Because of that, this solar, always any source, whether it is battery, whether it is solar PV panel, it always preferred that you take DC current from them. Okay, don't take high frequency AC current imposed on that. So what we have, so when it is grid connected, when the solar PV is grid connected, you need a DC-DC converter and then followed by an inverter, simple inverter that you use. When it is DC microgrid, then your converter configuration has changed. It becomes a DC-DC converter. Okay, a DC-DC converter that could have dual stage, that could have single stage, but single stage will do when it will do, let us say DC microgrid, you cannot. So if you have a, let us say a DC microgrid, okay, so this is the DC bus that is given by the DC microgrid, and here is the solar PV. Then you have the converter, DC-DC converter, DC to DC converter. When this voltage is defined, so you use single converter and extract MPPT, that is you do it in current control and then you extract power and deliver to this DC bus. But when this voltage is not defined, then you need something else. Then this may not be this converter may not be suitable to extract MPPT power, and also because the solar PV power varies like anything with the irradiance level, temperature level, everything. So that may not be feasible. Now this goes with solar. When you have wind energy, so grid connected, when it is grid connected, you need, when wind power extraction, what you need is AC to AC converter, because wind is going to generate 3-phase AC, and if you are connecting it to grid, you need a 3-phase output. So AC to AC converter. So in AC to AC converter, there are two possibilities. One is back to back converter, or what you use, matrix converter. Okay, so these are the two possibilities that you have for grid connected wind energy. Or if it is a a DC microgrid connected, then you need AC to DC converter. So, depending on what kind of converter, what kind of application that you have, your converter configuration is going to change. When it is hydropower, then same, you will see that for hydro and wind that almost things are similar. Okay, for hydro and wind, it is the power extraction is almost similar. So, for hydro power plant also grid connected, then you need AC to AC, and when it is microgrid connected, then you need AC to DC. So, battery energy storage, just for continuity I have added. So, you need a DC-DC converter, and for fuel cell you need a DC-DC converter when it is electric vehicle application, and then for microgrid also it is DC to DC converter that you need. So, here fuel cell output is low voltage and high current. Okay. So, you see different energy storage, energy sources will have its different type of output, and you have to deal with it, and power electronic converter is the only thing that you need to deal with it. Now, you see here characteristics of these three. Okay. So, I specifically put this slide in order to let you understand that whether it is wind, whether it is hydro, whether it is PV, you will have this kind of characteristics. Okay. And depending on the weather condition, depending on your operating condition, you had to extract. If it is a layman job, a layman and an engineer difference is, engineer always, we are engineers because we always design the thing, and why we design the thing? Because we want to optimize the system operation, right. Without, you put a solar panel and at your home a bulb is glowing, okay, fine, you have made it working, but when it is an engineer comes, then it should be solar PV that you install, you extract power at MPP, and then you glow that bulb. Instead of one bulb, you may glow at 2-3 bulbs. This is the difference. So, when we are engineer, we have to extract, since depending on wind speed, depending on water flow, and depending on irradiance, the MPP point are changing. So, role of power electronic will be to track power electronic converter on the source side, on the source side. The role of the power electronic converter is to extract the power at MPP, that is the sole role. So, if you have two converter, one will take care of the grid side, another will take care of the source side. The source side converter is going to deal with this MPP, whether it is solar, whether it is wind, whether it is PV, everywhere this MPP tracking will be there, and you need a converter in order to track this. Is that clear? Okay. So, need for a power converter and to control it to extract power at MPP. Okay. So, depending on characteristics, you need to implement the type of converter. Now, I am coming into a hydro power plant. Okay, hydro power plant. Now, what happens? The power, how the power is generated? So, you will have a turbine, water turbine, then it is coupled with a generator, right. Now, this, there is a water inlet and outlet, like steam input and steam output, this turbine and this generator. Now, depending on this water flow rate, as sir was explaining that in a river we implement several such turbine, and on the river flow rate the turbine speed will change, the turbine will rotate and power will be generated. Now, when it is river flow, then what will happen? The flow may not be constant throughout. So, this rotational speed will be variable. So, generator rotation will be variable, the output power from the generator will be variable, and how this is variable, that will depend on this, that will depend on its characteristics. Based on the water flow rate, the power delivered by the generator will be different, right. So, that is what variable speed operation is necessary. Okay. So, you have to allow variable speed operation. Constant, if you have a constant speed turbine, it will not do, because the application is variable speed and you are implementing a constant speed turbine, there is nothing out of it you are going to get. Okay. So, output power is proportional to water flow rate. So, power fluctuations will be definitely there, whatever I showed in the characteristics. So, control of power converter. So, then you role of third party, which is a power converter. So, you have source, you have turbine, and then you need a turbine generator set, then you need a third party power converter, which is going to make take measures in order to get your power at smooth operation. So, two options that we have is that depends on what kind of generator that we are going to use. One is permanent magnet synchronous generator that you must have heard of. Another one is doubly fed induction generator. Okay. Doubly fed induction generator, I personally feel, is one of the best engineering marvel. Okay. In motors, that is one of the best motor that I have ever seen in my engineering career. This is one of the most versatile motor that can be controlled in a very nice sense. I will explain one part of it. I will explain. So, this doubly fed induction generator were the state of art few years back for wind power extraction. Now, this permanent magnet synchronous generator are used. Last time we were in discussion with sir. Sir was telling for wind power application, this permanent magnet synchronous generators are getting issue like this permanent magnets are getting deteriorated because of this weather condition, because wind farms are generally at offshore. Wind farms are offshore. So, harsh sea weather condition it is installed. Because of that it is this issue with the permanent magnets of the synchronous generator is coming up. So, anyhow we will explain, we are not going with the motor part, but if you have the motor, how to control that we will see. Okay. So, this is CFSM is converter fed synchronous machine. Okay. So, any motor is not generator or motor, it is machine only, it is a rotating machine only. It is you that you going to operate that machine as either as a generator or as a motor. That is why always we use this term M, that is machine, and this is doubly fed induction machine. In converter fed synchronous machine, what happens? The stator of the machine is directly connected to the grid through a transformer, or stator of the machine is connected through a power converter or frequency converter to the grid, either through a transformer or directly to the grid, depends on what kind of converter that you are going to have. And doubly fed induction machine is stator is connected to the grid, but rotor is connected through a converter, that we will see. So, what is the role of power electronics? So, role of power electronics you can see here is vast. The grid integration part is there, where you control the power flow, you can control the reactive power flow, you can control the frequency, you can control the voltage level, those synchronization thing is there, and protection is there. In machine control, what we have? In machine control we have how we are controlling the speed of the machine. Okay. Here what we have the turbine generator set, the generator speed you have to control, the speed that you can control by controlling the torque. So, how we are going to control? These are the two methods, and then the construction of the machine. Then variable speed operation, if you pump energy storage, pump storage hydroelectric plant, then what you have is you have a reservoir. Okay. So, what you do is when you need power, use that reservoir water. So, you have a tank, you have turbine generator set, so you take water from here, and then so this is water flow, so generating mode. So, using this water, potential energy is converted into electrical energy. When excess power is there in the grid and you have to maintain the grid frequency, what happens when grid power increasing, what will happen? It is not like a DC bus, it is the frequency of the grid will increase. Why? Because the synchronous generator that is running, it is getting excess power, and its speed will, rotational speed will increase, and eventually the speed of eventually the frequency will increase. In order to maintain the frequency, why not to extract some power from the grid? So, you extract power from the grid, and using this turbine, now it will work as a pump. You pump back the water to the storage. Okay, this is how it can work. Okay, so that is why generating mode, pumping mode. Okay, and then excitation control we will see. Acha, typical rating mini hydro power plant, if we say, then typical rating generator rating up to, this is not a hard and fast rule there. So, typically 2 to 3 megawatt power level we can say as mini hydro power plant, but voltage level is different, up to 400 volt to 11 kV. Why for high power application we need to increase the voltage level? What is the reason? If anybody can answer. For high power level we need to increase the voltage level. What is the reason? What could be the reason why we increase? Loss. How will reduce the loss? So, power level increases. If we increase voltage level, then current will come down. Then the first thing apart from loss, what is the first thing that we are going to get is, in previous case, let us say we are having this much we had used, let us say when it is 400 volt, we had used this much thick conductor, because your current level is high, you have to use thick conductors. When you increase the voltage level, insulation thickness is not going to increase very proportionally. So, your conductor size reduces. So, your machine becomes compact. Low voltage, high current, machine size will increase. High voltage, low current, your machine size will reduce. You will have compact solution. Then this definitely I square R. So, I square R loss will reduce. I square I is reducing. I square loss R loss will reduce. So, 11 kV. If it is 11 kV, machine rating is 11 kV, or if not 11 kV, if it is a let us say 3 kV or something, it is not, 2 level converter is not sufficient to use. You have to use something else. Okay, that we will see. Okay. So, this is converter phase synchronous machine, So, let us see what are the components that we have here. So, first is, this is the generator that we have, okay, and this is the stator part, outer part is stator, let us say assume the inner part is the rotor. Then since it is a synchronous machine, so what you need? You need a DC field. So, you need this one. So, you need an AC to DC converter in order to make it DC. So, DC field you need. Why you need DC field? Because it is very simple. This operation means the working principle is very simple. Stator is a distributed winding, you supply with a 3-phase balance winding, you will have a rotating magnetic field, and then you have on the rotor you have another magnet which rotates and locked with the rotating magnetic field. So, if it is a DC, it is well suited and it will lock with the rotating magnetic field and it will run. And then you have a back to back converter. Back to back converter means this is AC, this is AC. So, this is DC, intermediate DC. So, this is back to back converter, this is an inverter, this is not inverter, I should say 3-phase AC to DC, this is AC, DC to AC. So, these converters are required to control the stator frequency and also the stator voltage, that we will see. Okay. Now, in order to match with this grid voltage where it is supplying, you might need grid transformer. These transformers are the major problem nowadays. People are thinking that how to remove this transformer. That is why the concept of solid state transformer has come up. So, solid state transformer, input is AC, output is AC at different voltage level of different frequency, same frequency. Even you can have same, even if you have same or different frequency at both the sides. This is a very versatile kind of transformer with high frequency insulation, high frequency isolation. Okay, this kind of transformers are very compact in size. So, this grid transformer how to eliminate. So, one of the ways you use a converter configuration so that it can capable enough to withstand this grid voltage. Then this grid transformer, because this is required only for voltage matching. Okay. So, back to back converter, this is a frequency converter, high rotational speed with high rated power. So, when you have high rotational, so you will see that doubly fed induction machine, you have windings on the rotor. Okay. So, the rotor itself, inertia of the rotor itself is high. So, we cannot run it at very high speed, windings will come up from the slots. Okay. When it is high speed, definitely it will be a compact size. Okay. So, here since you have a back to back power converter, it is very easy to control speed from 0 to rated speed, and this is one of the very popular requirement. rated torque from 0 speed. Rated torque from 0 speed, I can tell you what it is physically, how it can be explained. I do not know whether you have seen hoist or not. So, what is hoist? So, in industry if you go, so let us say there is a heavy component is kept here and you have to take it to that place. What they do is there are hoist throughout the, means there is a grid. So, hoist can come, lift it up and bring it to that different place, right. Now, what happens, the hoist has lifted it up, okay, lifted it up. So, in order to lift it, it has to balance the gravitational force which is pulling it. So, that means you need a torque on the hoist shaft, you need a torque, but hoist is what? It is stationary, right. That means the hoist is stationary, means it is at 0 speed, but it has to apply the torque. This is the condition, rated torque from 0 speed, that means at 0 speed you need a torque. If this is a very crucial requirement, what happens, sometime you have torque pulsation at 0 speed, what will happen, the hoist cannot hold that object, it will vibrate because there is a vibration in torque. So, it will vibrate. So, this thing you have to keep in mind, and this is nowadays this is not a very difficult task. Now, the problem with this configuration is, you can see here the converter has to cater the entire power of this machine. Okay. So, converter rating is same as that of machine. Now, you see here, since time is almost running out. So, just directly I will come, these are simple thing, grid, reactive power control and all. The main thing is this one, STATCOM. Now, what happens here, I omitted one important thing, which is capacitor. So, what happens, this capacitor and this thing, this part, as I told you, this HVDC, LCC converter, instead of LCC converter, if you use a VSC converter, it can support the grid ancillary services. So, one of them is STATCOM. So, it can act as a STATCOM and support the grid. This is one of the advantage that you are going to have with this converter configuration. Okay. So, now this control of this converter. Okay. Now, the control of this converter has two part. You can see here, one is, this is the grid side converter, grid is there, grid side converter, and this is the machine side converter. Okay. So, this is machine side converter. So, what is the philosophy? The philosophy is, from the grid you maintain this DC bus voltage, at a fixed value, okay, whatever value, that depends on what is the design thing. So, you fix the DC voltage and then you let it work at MPP. How it work at MPP? You have to control the speed of this machine at that particular speed, so that the power extraction from the machine is maximum for that particular water flow condition. Okay. So, how it can be done? So, what it does is, the speed control it is doing, speed control. So, speed control, so you will have a set speed which will come from MPP controller. Okay. So, MPP that you are going to implement, from there it will give you the how much reference speed it should be at this condition, and this converter, the role of this converter will be to attain this set speed. Okay. So, it will sense, as I was telling you, this sensing part is one of the major thing. Then you have the controller, and with this it will generate ID, IQ, whatever it is up to you, because it is convention is up to you, but it will generate the torque producing component, whether it is ID you are taking as torque producing component or IQ. So, that torque producing component, and accordingly it will adjust the using the current controller, it will generate the reference voltage, and then it will set the converter voltage here VC, so that the current here becomes the desired current, so that the speed can be attained. This is what. So, reference speed from MPP, this reference speed you are sensing, then you will generate the reference current, from reference current you will generate the reference voltage, and accordingly the converter voltage will be adjusted for that MPP condition. Is that clear? This part is clear, otherwise I will again explain this part. Any doubt anybody is having, then I can explain once again. Okay. Now, in the grid side, it is conventional thing, there is no difference. It is voltage sense, the DC link voltage control, then reactive power control. From here you will have ID and IQ stars, grid side current, and then you are sensing the IDIQ, and then you are converting into ABC to DQ, and then there is a current controller, you are generating the reference voltage for the voltage control of the converter. Okay. So, now it is back to back. Now, you can see here why we have back to back converter. So, one is doing the MPPT and one is taking care of the grid thing. Okay. So, this is how this is a typical control that I have presented. Now, on modification of this you can figure out what are the gaps that you are going to have with this, and then accordingly you can control. Now, this is the typical single line diagram. So, bypass means what they are saying, just quickly I will tell this. When this is synchronized, this machine is synchronized, what they are saying, they can remove it and they can bypass it, and then let it run from the grid itself, the transformer output itself, because if converter is off, so converter losses become 0. Okay. So, possible service of the converter unit. So, that time you can do the servicing of the converter unit. Okay. STATCOM operation, I already explained this, that reactive power flow can be controlled with this DC link capacitor. Definitely size of the capacitor will be different than when you are not doing reactive power control. Okay. Now, doubly fed induction generator. In case of, so the difference here is, you can see here, the instead of DC excitation it is AC excitation, because in induction machine, the rotor, the beauty of induction machine is, whatever stator you are doing, the rotor will just do the mirror image of the same thing. Okay. This is the beauty of induction machine. So, that is why if stator is AC, then definitely rotor will be AC. So, what it does is, it controls the rotor power, that I will come, I will show the figure, then you will understand. So, here you can see here, there since rotor power is much less, rotor power is S into PG, where PG is air gap power. So, this power is much less. So, rating of this converter is much less compared to the previous case, where rating of the converter was same as that of the machine rating. So, how this rotor part is controlling, the philosophy I can tell you. What happens? So, this power, this is the synchronous generator, this power is coming, which is PG, air gap power. Okay. Now, this power is S into PG. Now, as you want to change the speed of the machine, if you control this power, that is either, so if you see here, so this is the torque speed characteristics, torque slip. Okay. So, let us say it is operating as a motor and you want to make it operating as a generator. So, if you start, so when it is operating as a motor, so the rotor power is positive, because slip is positive, rotor power positive. So, rotor power is coming up. Okay. So, the power that is available on the rotor shaft is 1 minus S into PG. Okay. Now, what you do is, let us say this though this is the diode bridge rectifier, instead of diode bridge rectifier, if you have a converter like this, which is I have shown previously. So, what it is going to do is, it will feed power from this side also, it will start feeding power from this side also. So, what will happen? Your operating point will keep on shifting from here, and there will be a time it might happen, the power is such that the power that you are injecting, now power is coming from both the sides. Okay. So, the machine will operate here. If you further increase power from rotor side, what will happen? It will now start going to generating mode, and it will operate depending on how much rotor power that you are injecting. Depending on that, the machine will operate as a generator at this point. Is that clear? Depending on, so how much rotor power that you are communicating, that means why communicating, you can either operate as a motor or as a generator, depending on how much power that you are injecting to the rotor or taking from the rotor. Depending on that, the operating point on that characteristics curve will be decided. So, this can be done. Instead of this, this can be done using a back to back converter. Okay. This is a back to back converter. So, here the power flow is bidirectional. You can either extract power from the rotor or inject power to the rotor, and finally you can operate this as a generator. Okay. Now, as I told you, the voltage levels are different. So, what you can do is, depending on voltage matching, voltage matching, what you can do is you can use multi-level converters. Okay, multi-level instead of two-level converter, what you can use it, multi-level converter like 3-level NPC. Why I am saying 3-level NPC? Because 3-level NPC were invented, reported long back in around 1980s. Okay, but nowadays it is a state of art. NPC is a state of art and it is used. So, it is one of the versatile multi-level converter that we are using in the industry. So, this 3-level inverter we can use instead of 2-level inverter. Now, people, when I ask to my students in class, generally people say that we use multi-level converter because we get nice output, like stepped output from the, I will show you how it looks like. This is the multi-level output that you have in 3-level inverter. Okay. So, people say that in order to get this we use multi-level. No, we do not use to get multi-level output. Multi-level output is an advantageous outcome out of using multi-level converter. Okay. This is the advantage that you are going to get out of it, but this is not the desired thing that we are looking for. Means this is not the reason why we are using multi-level converter. The reason is, here you see the total DC link voltage is there, total DC link voltage is VDC. So, here this is half the DC link voltage. So, the voltage that this device has to withstand is half the DC link voltage. In order to reduce the voltage across the device, we use multi-level converter, because the maximum voltage withstand by whatever switches, power electronic switches available in the market, which is limited, but we have to go for higher power level. So, this kind of configuration we can introduce, so that low power devices can be used for high power applications, and the topology is completely changed. Because of this, with low power devices, high power application is feasible, and this is the outcome that we are going to get. Because of this, what is the advantage that we are going to get is, the output filter size is reducing. This is the another advantage that we are going to get from this thing. Okay. So, it is already a state of art, large voltage step. Now, we do not have large voltage step across the devices. Also, the voltage steps that is appearing across the machine is reducing. Okay. Because one of the major reason of machine failure is bearing current. Okay. That bearing current comes because of common mode current. That common mode current comes from common mode voltage. If you can reduce common mode voltage, definitely the failure of the bearing will be reduced. So, 3 output voltage levels. Okay. So, this is fine. Another thing is so like this. So, here what I mean to say is, so here back to back converter, what you can use it, you can use, depending on this voltage level, what you can use is multi-level converter that you can use in order to cope up with the voltage level that we are increasing. Or one of the very popular multi-level converter that is very much now popular in HVDC application. Almost every HVDC application, every DC application is using this converter. It is a modular multi-level converter. Okay. You can see over internet, there are many companies in China and all over the world, they are preferring this converter and they are implementing. These are voltage source converters, voltage source converter, voltage source converter. So, this is back to back converter, back to back converter. Okay. So, 2 back to back converter also we can use. The advantage of using this is, it is a modular in structure. So, each module looks like this. So, if there is a problem with one module, you just replace it, downtime reduces, which is very much required for industry, downtime reduction. Okay, scale up. If you want to increase the voltage level, you just add blocks, you add blocks and increase the voltage level. So, if you can come up with the, so the transformer less operation is also possible, because voltage level you can match. Okay. But the problem is, definitely nothing comes free. The problem is structure becomes very complex now. Okay. Control this capacitor voltage balancing, this capacitor voltage balancing, you need to have a different sorting algorithm you have to implement in order to make the capacitor voltages balanced. okay, complex control. Okay. Now, this is not MMC output, this is one of the multi-level converter output. So, just I want to show you that as number of level is increasing. So, here number of voltage levels are increasing, so that this is phase voltage, this is line voltage. So, that current that we are generating, the filter requirement is reducing. So, multi-level converter if you use, it is voltage matching you are doing. At the same time, what you are getting is, you are getting filter size reduction and other advantages that is coming up also you will have. Okay. So, back to back converter that we are going to use for this hydro power plant, either it could be rotor fed or it could be a stator fed, and this back to back converter you can have different configurations. So, conclusion is, power converter play a major role in renewable energy extraction and integration. Without power electronic converter you cannot think of. And then converter topology depends on source and load requirement, that I explained in very first slide. And then the two options that I told, doubly fed induction machine and converter fed synchronous machine, these are the two options that we have. And back to back converter is the one of the popular solution, because if it is a definitely if it is a DC, if you have to connect to a DC grid, you connect a 3-phase AC to DC, and then you subsequently use DC converters whether it is required or not. Multi-level converter topologies like NPC, MMC are preferred. Now, see why I just limit myself to NPC and MMC, because NPC is very stable, MMC is also very stable. Since MMC is suitable for HVDC, now MMC they are using for, there are papers where MMC they have used for motor drives application as well. Okay. So, these are the references. So, I have to stop here. Any queries I can address from offline and online participants.
Sir, in case of multi-level inverter, so when we increase the level, that means the harmonic content will be lesser, but as well as the power loss in the switching loss will be more. So, what will be the ideal level?
Now, switching loss in multi-level converter are less, because when it is multi-level converter, inherently you have to use switching frequency, the carrier frequency that we use for let us say 2-level converter, which is 10 to 20 kilohertz. Here we use much less, maybe 2 kilohertz, 1 kilohertz. So, switching losses are negligible. Yes, conduction losses we have to see, okay, that we have to compare. This many a time I face this question, like how to compare the efficiency. Efficiency comparison I am not happy with, because efficiency comparison you need exact same situation, exact same operating condition, and then you can compare the efficiency. So, commenting on efficiency whether it will increase, decrease, that is very hard to say. But I can say that switching losses in multi-level converter are much less, because you already have stepped output voltage waveform.
So, what is the ideal level that we should go for?
Now, ideal level will depend on what? It is not harmonic content, it depends on the voltage level.
Voltage level.
Yes, yeah. Let us say the voltage level you are happy with 2 modules. Here in, let us say I take the example of MMC. If 2 module per phase you are able to achieve that voltage level, then use 2. With 2, whatever voltage level you are going to get, that is the voltage level. But if you want to increase voltage level, you have to increase this. So, this is the primary requirement, you have to match the voltage level, and with that whatever multi-level output you are getting, that is the advantage. Okay. Thank you then.